After entering the stock removal tolerance for line number 8 as 0.63, then we have to start entering for line number 11. Okay, what you do? We have to draw a balanced dimension line just above 11 for the same span of 11. So now we have to find the tolerance for this balanced dimension 10 using a looping technique. So let us not use the OSP. Let us visualize without physically making the tolerance loop. So from left end of 10, I am moving up, then it goes along 5 and it is moving up. From the right end of 10, it is moving up. This is where both the loops are merging. The only line over which the loop passes is 5. So what is the tolerance of? Okay, what is the tolerance of 5? It is 0.25. So that 0.25 will enter here. Okay, now we have to find the stock removal tolerance for 11. Okay, 0.13 and 0.25 both are added to get 0.38. Okay, so 0.38 is the stock removal tolerance for line number 7. So line number 11. Similarly, you have to find out the stock removal tolerance for 17. So you have to draw a balanced dimension line above 17. Then you have to use the tolerance looping technique, and you have to add the tolerance and this tolerance. So when you have completed everything, your tolerance chart should look like this. Okay. Now what is next step? The next step is to fill up the mean value of stock removal. The mean value. Okay. How to find the mean value of stock removal? Let us start from line number 8. So line number 8 is the dimension achieved due to the phasing operation done in stage 60. The stage 60 is finish training stage. For the finish training stage, this minimum stock is 0.5. The minimum stock per phase is 0.5. In that case, if I put if I put 0.5 here against line number 8 under the mean column, will it be okay? Suppose I am putting 0.5, okay, under the mean column of stock removal against line number 8, will it be okay? It is going to be 0.5 plus or minus 0.63. That is the stock removal, okay, for line number 8. Okay, what will happen? You will see. So 0.5 plus or minus 0.63. If you decide, then okay, 0.5 minus 0.63 you are getting minus 0.13. 0.5 plus 0.63 you are getting 1.13. Okay, what you understand? The stock removal, the stock is not sufficient in some of the sample, minus 0.13. The stock is 1.13 in some other samples. So this is not right. Okay, so fixing in 0.5 as the mean value for line number 8 is not right. Then how to find out the mean value? Okay, this formula you are going to use. Okay, are you able to see this formula? So for line number 8, the stock removal tolerance we have found it as 0.63. The minimum stock for line number 8. The line number 8 is the dimension achieved during finish training 1 stage. So the 0.5. That 0.5 you are adding here. So how much you are getting? 0.63 plus 0.5, 1.13. So this 1.13, okay, now you are adding, you are okay entering against line number 8. Okay. So now if you have a stock mean of 1.13 with a tolerance of 0.63, a minimum of 0.5 will be maintained, okay, in any sample. 1.13 minus 0.63, you are getting 0.5. So similarly, you have to start entering the mean value for all the remaining machine tool lines. 0.38 plus 0.5, 0.88. 0.51 plus 0.5, 1.01. 0.26 plus 0.5, 0.76. 0.76 plus 0.5, 1.26. 0.155 plus how much you have to add? So now this is the dimension achieved during grinding operation. For grinding operation, the minimum stock per phase is 0.1. So 0.155 plus 0.1, 0.255. Again 0.255. Thank you.